Good morning. I want to take this opportunity to welcome all of you to OSU Okmulgee this morning. This week represents golden days for OSU Okmulgee. And the reason that we're celebrating in this golden day Good morning. I want to take this opportunity to welcome all of you to OSU Okmulgee this morning. This week represents golden days for OSU Okmulgee. And the reason that we're celebrating in this golden days on October 3rd, the institution will celebrate its 50th anniversary. In 1946, October 3rd, the institution took its first class, enrolled its first class of students. And at that time, that was 500 veterans. And for a long period of time, OSU Okmulgee served veterans, and the institution did not get state appropriation. The way that the institution was financed was through the benefits that veterans had in the Veterans Administration. So we have changed a great deal over the years. Today, what we wanted to do was ask numerous people from the various advisory committees to come together across campus so that we could recognize the service that advisory committee members provide this institution. Totally, we have approximately 25 different advisory committees that help us with each of the different programs of study that we offer here. I think if I could just go back just a bit, when President Bennett, H.D. Bennett, was president of the Oklahoma State University system, he is the individual that was responsible for the creation of OSU Okmulgee. And as you look at the history of the institution and the way it was created, in 1945, this had been built in 43 and served as an Army hospital until 1945, and then the facilities at the end of World War II were closed. So the people of Okmulgee and the greater Okmulgee area looked for alternatives for this institution. And President Bennett at that time knew and visualized with the GI Bill of Rights that there were many veterans coming back to World War II that needed vocational and technical education of some kind. So that's he was able to secure the institution for that purpose from the government. So it's always interesting when we have our accreditation visits is that the institution does not have a charter, or we don't have any legal kind of authority. At that time, President Bennett was a very strong individual in the state of Oklahoma. Essentially, he created the institution. But I always say that we don't need a charter now because we're a line item in the budget from the state of Oklahoma, so we feel like that's probably better than anything else that we have that truly says that we are established as an institution. So President Bennett started the institution. I would be remiss if I didn't mention the first director of the institution, Mr. Keith Cobell. He was a very visionary person. I did not have the opportunity to know him, but when you look at some of the things he's done and some of the things that's been reported, he was a very visionary institution and could see what an institution that prepared people for employment could do. And then finally, and Mr. Miller, Wayne Miller, was one of the original faculty members at the institution in the area of agriculture. And then from 1963 until December of 1983, Mr. Miller served as director of the institution and certainly did an exemplary job and continued to move the institution forward. So those three individuals, when you look at people that founded OSU Okmulgee and had a very significant impact on its development, we would have to credit Mr. President Bennett, Mr. Cobell, and Mr. Miller. I was thinking the thousands of men and women across not only across Oklahoma, but many contiguous states that served on our advisory committees. It's literally thousands. And you know, to try to figure out how you would place a value on the contributions those individuals made to the institution would be impossible. Because you just look at we meet at least with each advisory committee 2 times per year. So if you just think about the amount of time that you have given up as members of advisory committee members to come and meet with us, it doesn't count anything else. That's just the time that you come, because obviously advisory committee members don't get paid or anything like that. It runs into millions of dollars in terms of the amount of time that advisory committee members take from their place of employment to come and meet with us to help us think about and design programs that better prepare young men and women for the world of work. So this morning, we do want to say a formal thank you to all of the advisory committee members and the community people that are here for the support that you have provided and are continuing to provide OSU Okmulgee. I hope each of you have a program, and got a program, and I see the flow of activities as they will take place during today. But before we move into the program, I want to recognize all advisory committee members by asking Mr. Dave Saylor, who is on the platform with me, to come forward. This same recognition will be repeated this afternoon in each of the instructional departments as the department heads and faculty in that department recognize their advisory committee members. But to symbolize that, we want to recognize that Dave, who first became associated with OSU Okmulgee in 1959 and has served in a continuous fashion as an advisory committee member in the air conditioning and refrigeration technology department since 1962. And I'm not sure that Dave's ever missed a meeting, and if he has, in all that period of time, you can probably count the meetings that he's missed on one hand. So he's really been a loyal supporter of OSU Okmulgee and has been an avid participant in the development of the program study as it relates to the air conditioning and technology department. This afternoon, each advisory committee member will be given a certificate, and the certificate will say Oklahoma State University, Okmulgee, celebrating 50 years of success and building the foundation for the next half century. Recognizes David F. Saylor for dedicated service to OSU Okmulgee as a member of the Air Conditioning and Refrigeration Technology Advisory Committee. We also have a book. Dr. Larry Davis did a history of the institution several years ago, and we'll also be presenting each member of the advisory committee with a book of the institution. And then finally, we have a lapel pin that was created specifically for the 50th anniversary, and so this afternoon advisory committee members will also be getting lapel pins, so I'd like to give David his now. Okay. Thank you, David. We appreciate your service.
Thank you very much, Bob. I think you singled me out for this job because I've been around so long, and it's one way that maybe get me to retire from this thing and make room for some younger guy to get on the advisory committee, and I'm going to do that, as a matter of fact. But before we go any further, I'd like to point out to those standing room folks in the back that the best seats in the house are empty and right up front. If you care to come forward and fill the chairs, there's lots of room up front. When I first started visiting this campus in 1959, I was impressed by a couple of things. One of them, of course, was the obvious antiquity of the facilities, the instructors and the staff working in buildings that were left over from World War II era, the departments using homemade, self-made trainers, equipment that was cast off from industry or wherever they could find it, and the selfless dedication of the staff and faculty alike is what really impressed me. Working in those conditions and turning out the products for industry and business in America was really something that has made me very proud to be associated with this industry, and I think I speak for all advisory members when I say that. Those folks at that and working in conditions that were certainly less than up to date. And we've seen a lot of changes. We've seen most of the bad things go away. You're in wonderful facilities. We've got wonderful equipment to work with, new programs coming all the time. I think there's probably still some room for improvement in the pay end of this thing, but that's another issue. But the selfless dedication of the folks on staff and on faculty, I think, remains and is one of the beautiful things about this school. This school has little difference from a business. It has a product, and it has a plant to turn the product out. The product certainly is the student who is headed for a job in any of our industries. These students are employed worldwide. The clients for this business are the businesses and industries of the world. We're fortunate this morning to have with us a representative of one of those very large corporations in the United States of America, which is a worldwide entity, and that's Caterpillar Company. We have with us a man who has been 27 years with Caterpillar in their Aurora plant, a civil engineering graduate of the University of Wisconsin, and is now the manager for advanced concepts for products at that plant. Tom Muller is going to talk to us this morning about 2000 and beyond, the evolution of equipment and construction, and how that will affect the needs of institutions like this to turn out products for these clients. Tom?
First of all, I want to thank Dave and Bob for having me here. This is a rare opportunity. I really enjoy doing talks like this, especially on universities. This is a great opportunity. Things we're going to talk about today are the future. What's going on? How does this university react with all of the technology that's going on out there? This is a technical talk, a high tech talk. Now, technology is a very fun thing, especially for me. Now, everybody out here in the audience looks around and they say technology, yes, we use it. The really neat thing about technology is it's all around us. We use it every day and we don't even know it. That's the great part of it. This university is a big part of that. I want to see a show of hands around here. How many in here, don't be embarrassed, how many in here have never programmed a computer? Just put your hand up here. Keep them up. You got cruise control on your car, put your hand up. That lost everybody but a couple of them. You got AM/FM radios in your car that you program in the stations. You're a computer program. You don't even know it. Every time you fire up your car, you fire up a computer. It's all electric control. Every time you run the telephone, computer. You go into the ATM, you put your little card in there, punch in all these numbers, you run the computer. You're doing your work for it. Technology, it's all around us, and it's fun. Now, we're going to talk about this technology today. We're going to talk about the future. We're going to have some fun, and we're going to talk about change. You want to back that one up, Rick? We're going to talk about the future technology. What's happening in the future? Why should you be concerned with the future? You're going to live the rest of your life there. Think about it. Just think about it. My job today is to get you to think outside your box. To get you to think outside of your normal comfort zone. Shift your paradigm. Most of us with gray hair or no hair, we've got bigger walls in our box than most of the younger people. The fact is, we try to get the younger people to think inside our box. This is what works. Their walls are not as big as ours. So I want you to think outside your box today. Shift those paradigms. Just look at all of this stuff we're going to talk about with an open mind. Remember one thing. Mind is like a parachute. It only functions when it's open. So you've got to look at this stuff with an open mind. We're going to talk about the future. We're going to have some fun. Every we're going to have a little fun. We're going to talk about change. Now, my job is to look at the future. My job at Caterpillar is to look at the businesses that we are in, whether that be general construction, logging, mining, whatever it is. Try to look at those businesses and try to look at those businesses 10, 15, and 20 years ahead, down the road. What's that business going to be like? Take that vision of that business and then try to figure out what kind of equipment it's going to take to accomplish that business 10, 15, 20 years out. Take that vision of that machine, that piece of equipment, and fold that back to today in 3, 4, 5, or 6 year increments, depending on what our NPI, our new product introduction schedule is for that. Fold that back. If the technology is available, we'll schedule that in our next update. If it's not available, we have to go out and invent that technology. The best way to be able to predict the future is to invent it yourself. That's kind of what we're all about. We're going to talk about change. Change is all around us. Nobody likes change. But change is the only constant. There can be no progress without change. If you always do what you always did, you always get what you always got. That's not good enough anymore. It's not good enough in today's society. So we're going to talk about that. Now, I was going to take this out, but I decided to leave it in. Because of exactly what was spoken about up here before. Several years ago, CAT came out with this new symbol. I don't know if maybe some of you can remember, it used to kind of be a stylized C. They came out with it. Now, I'm an engineer. Now, if you got kids that are going to be engineers, those are the ones that are always tugging on your pant leg. They're saying, Mom, Dad, why? They always keep asking why. Can you answer why? You know, why does this do that? Can you tell them, then what's their next question? Why? They just keep asking why. Well, there are kids that can take things apart and put them back together. They're going to grow up to be engineers. So Cat came out with this new symbol. Old time here, he looks at this and he says, what is that triangle in there for? Why is that triangle? What does that mean? Anybody in here know? Don't feel bad. Nobody at Caterpillar knows why that's there either. I've asked them. It's just there. The best answer I had was one of the old vice presidents of engineering. I says, why is that in there, Chuck? He says, I don't know. I don't know what that means. What does that mean to you? This is kind of what it means to me. As an engineer, the triangle is the simplest, strongest structure there is. You think about it, all your bridges, all your trusses are made of a series of triangles. You push on one side of the triangle, the other side is folded up. You push on the corner, the other corner is folded up. If that was a rectangle, and you push on the corner of the rectangle, it would collapse. You take that, and you run a brace from side to side. Make two triangles out of it, then it's strong. But as a rectangle, that is very, very fragile. That triangle, to me, is made up of these elements. It's made up of the cat, the dealer, and the customer. And we have to work together as a partnership to make that succeed. We have to work together and communicate. Our job is to make the customer successful. That's our job. If we do that, we will be successful. You take that same model, that same concept, and you take that and you say, okay, we've got a customer here. Your customer here is those students. Those students, when they go on in society, that's your product, that's your customer. Over here, it's going to be a Caterpillar, that's Okmulgee. That's the university. Over here is your advisory boards, people in this room. Every time you get together, you're communicating. You're communicating what it takes to make that product, that customer successful. Keeping up to date. Communications, feedback. Believe me, Wheaties is not the breakfast of champions. Feedback and communication is the breakfast of champions. Okay, nothing serious. Let's have a little bit of fun. Now, most of us are like this little guy coming on the screen. We're being drugged into that 21st century. We really don't want to go out there. It's scary out there. It's scary out there. We have to be going out in that 21st century. My job, on my job, we have to say, those who say it can't be done should step aside for those who are doing it. Because it's happening. We can almost do anything. Think back to the Gulf War. All of a sudden, these weapons, these smart weapons are coming out. They were working on those smart weapons when I was in Vietnam. They were working on them before Belfort up there in Virginia. So that technology that they have there is not new technology. Yet you're seeing it today. So you can imagine some of the stuff that they're reworking. But we're show you some concepts and some machines. Some of these you definitely will see in production. Some of you might see in production. Some of you won't see in production. We're going to talk about some trends and how these trends are affecting the design of the future construction equipment and how these trends are going to affect the design of this university and its courses and its curriculum. These trends are happening here in Oklahoma. They're happening back up in Wisconsin. They're happening in Europe. They're happening in Mexico. They're happening all over the world. And how these trends are going to affect us. We're going to show you where we're going, and in some cases, we're going to show you what we're going to go from there. And again, continuous change. Continuous change. Continuous change for this university and for us means continuous improvement. We don't have time anymore to say, this is good enough, look what we did. Because as soon as we bring that out, somebody's going to grab that, reverse engineer it, add a little widget to it, and pass it by. We don't have time anymore to do that. Continuous improvement, continuous changes in your curriculum, update that to the latest technology. You look through your brochure, some of the things that you can see this afternoon. Look at that and go back 5 years. Half of the terms you see on there that are going to be demonstrated today weren't even in the vocabulary. That's how fast this stuff came. Now, we said we're going to have some fun. Now, before we look at some iron, we got to have a little biology lesson. Now, the brain is divided into two halves. You got the right half of the brain, and you got the left half of the brain. The right side of the brain over here, that's the conceptual side, the artistic side. The creative process goes on the right-hand side of the brain. The left-hand side of the brain, that's the analytical side. The rational process goes on the left-hand side of the brain. Now, everybody in here is either right brain or left brain oriented. There's no right and wrong side. That's just the way you are. That's your makeup. From now on, you have to believe that we can do anything. So we got to get you thinking from the right side of the brain. Before we can do that, we got to figure out what side you normally think from. So I want everybody in here, stick your hands up here as high as you go. Stretch a little bit. And you always tell myself, oh, that feels good. When I say go, all I want you to do is go. Ready, go. I just want you to look down now and see what arm's on top. More than likely, not in all cases, more than likely, your right arm's on top, your right brain oriented. Or if your left arm's on top, your left brain oriented. Now, the first thing everybody's supposed to do is look at their neighbors. All right, now, one more test. One more test. This time, when I say go, what I want you to do is I want you to put your hands together, interlock your fingers and your thumbs like that. Ready? Go. I just want you to look down and see what thumbs on top. More than likely, again, not in all cases, more than likely, if your right arm is on top, your left thumb is on top. Or if your left arm is on top, your right thumb is on top. If that's the case, that just means flexion. You go from side to side. If your right arm is on top, your right thumb is on top, your right brain oriented. Your left brain oriented. Okay? Now we talked about change. I want to show you what change feels like. Like I said, change is the only constant. I'll give you a perfect example. Most of you are probably businessmen or in business of some sort. If you are running your business, depending on what it is, I'm going to say 10 years. If you are running your business 10 years from today, exactly the same way you're running it today, you're going to be out of business. My job is to look at the future. I'm guaranteeing you that. I'll guarantee you that. You might sit there and say, well, Tom, that's not crazy because I haven't changed my business for the last 10 years. You got a little beeper on there and carrying your cell phone down the road. It has changed and it's going to change. I'm talking about this change, what change feels like. Speed and honesty comes on this test. Put your hands back up in the air. This time when I say go, as fast as you can, I want you to put your hands back together with your other fingers and your other thumb on top. Go. Now there's another thing. They're trying to figure out which one. More than likely, you made the thumb but missed the fingers, right? Take them apart, put them back together the opposite way as you did last. Feel that. That weird? That's how weird those other side brainers are over there. But that's change. That's change. You sit there and you feel that and say, it doesn't quite feel right, but that's change. There's nothing wrong with it. It just doesn't quite feel right. That's change. That's change. Come back up. This time when I say go across your arm, just the other arm. Go. Yeah. All right, from now on, you can do anything. So let's take a little look at what the future could hold for us. How about a bulldozer, D18, something like that? We've got probably more right-brain people than we have left-brain. When you look at that, and people start laughing. My standard reaction to that is you're thinking inside your box. Because everybody kind of knows what a bulldozer looks like today. But they don't have to look like that. They're not going to look like that. We do some stupid things today if you think about it outside your box. What's the most important thing on a bulldozer? The most important thing is this blade up here. That's what does the work. It runs around pushing dirt, whatever it is. You take that off there, you can probably punch holes in the walls, but that's about it. Put the blade on there, now it's a useful tool. If it's so important today, why do we take the tallest, widest thing we got, that being the radiator, push it as far forward as we can get it, and then complain because we can't see the blade? Think about it. Think about it. The fan doesn't have that problem. He's up here, you can see that thing. That blade on one end, pressure on the other end, that'll work. That'll work. Track loader, same basic machine, same basic module in the rear, except up front, so the blade. How about this? Want to take a guess what that is? Scraper. Front wheel steers, old track system, articulation joint here, bowls up front. Today on a scraper, the bowls in the back. We pull it. They didn't even have sense to push it through the feet. It's more efficient. Horses don't pull the wagon. Horses push the wagon. You stop thinking about it. They push on the harness, which is attached to the pumps. They're really pushing that front. See, that's more efficient. How about this? Motor grader. Again, front wheel steers, new track system, articulation right here. Now the operator just sits right here, right where you can see the blade, right where he should be, right close to his work. That'll work. I've got some people out there say, yeah, how does he see the back up, right? There's TV cameras in there. Probably half the mobile homes going down the highway, got TV cameras in the day so they can see the back up. It's an excavator. Takes a little explanation. On an excavator, from here, from the sprocket to the idler, you want that to be short so it's maneuverable. When it gets to where it works, you want that long. So this just telescopes out, and that idler goes down in there. Now the operator, he sits right here on the boom, right where he can look down and look at that bucket. He goes up and down inside that boom. Not only does he go up and down, but the counterweight back here goes up and down also. Today it doesn't, it just kind of sits like that. We might as well use that. Use that to help us with that work. Wheel loader. Kind of looks like a ugly bone. Anybody familiar with wheel loaders out there? Truck. Front wheel steers, back wheel steers, center wheel drivers. Guys said, Tom, those are kind of neat, but how the heck do you get on those? How do you get on an airplane? Same thing. Ladder just telescopes out, walk up the ladder, hop into the cab, and it's on the side. That'll work. You can do that. You can do anything. If I want to take a guess what this is. It's kind of cute a little bit. Most people say that's a backhoe loader, and they're half right. Backhoe loader or loader backhoe, but it's not a backhoe loader, it's a backhoe four-hole loader. If you look at that, it can dig going this way, or it can dig going this way. Today, most of the stuff that you have, all the stuff they have, just digs going backwards. It's backwards and forward. In fact, the contractor can dig just as much cable out of the ground going forward as he can going backwards. Maybe you can see it just a little bit better. Backhoe four-hole loader. How about this? This is a small bulldozer. Little D4 size. So same basic body again. But now it's the same old platform, just does a little bit of work. I've got a question for you. How long do you think it's going to be before these two machines, when they go down the highway, it look like this? Want to take a guess? 5 years? Usually get 10 years, 15 years. Obviously, you're not familiar with Caterpillar's legislations, the Challenger, and Look at that. Look at this piece. This has been in production for several years. You look at that. You look at that little D4. Take that little D4, instead of having that in the front, make it back. Take off that flop, put on a drawbar, put it on the hitch back. Take that tire, hook it up, make it a little bit bigger, so that you got roll front clearance. Take this snout, stick it out to the front here, so you get better balance. Hit that cab up in the air a little bit. What does we got? 35, 45, 50. Future is here today. This stuff is coming. It's coming faster than most people think. It's coming. Here's a trend. This trend is going on around the world. It's going on, and this is the trend that's probably affecting the design of our equipment more than anything else, and it's affecting the design of your curriculum more than anything else. Tomorrow's machines are definitely going to be Electro-X. Now, what do I mean by Electro-X? They're going to be electro-hydraulic, electromechanical, electromagnetic. Electro-X. Electronics are going to be used to control the hydraulic action, to control the mechanical action, to control the pneumatic action. Electronics, small microchips, small computers. You look at this school. You look at the one off to the back over here. They're building a new building. In that building will be electro-hydraulics, Electro-X, those small computers. How fast is this changing? Anybody buy a new car recently? Truck? Anything? What'd you buy? What? Camaro. Got a lot of snivvies on it, airbags, anti-lock brakes, the usual stuff. There's more computing power in that car than on the Apollo space mission that went to the moon 25 years ago. And you're driving it down the highway. More computing power in that car than on the Apollo space mission. And that includes the rocket and the lunar lander put together. And you're driving it down the highway. Everybody got a watch like mine? One of these digital watches, got a chronograph on it, alarm, stuff like that. I've got more computing power on my wrist than was available in the world in 1961. Think about that. There's many people out here that remember 1961. It's not that long ago. I got more computing power on my wrist than was available in the world. Somebody's got a birthday. You invited to the birthday party. Comes the day and you forgot to buy him a gift. So you stop off at the Hallmark store on the way, and you buy him a $2.59 birthday card. And when you open it up, the place, happy birthday, everybody say no. You give it to the guy that night, he opens it up, and he's going to thank you, Tom, that's very generous of you. Later on that night, he throws it away. He's thrown away more computing power than was available in the world in 1950. Cost me $2.69. That's how fast this came. I had a tremendous awakening of this just about a month ago. I was down at the University of Illinois at NCSA, the National Supercomputing Association. 10 years ago, this opened with a Cray supercomputer. They had to pay $2.5 million for this $14 million computer. It's a big computer. This is so fast that it had to be liquid cooled. It was designed so that the wires were short because it's designed on the speed of light. And the speed of light is fast, but it still takes longer to go through something this long than it does this long. So it's designed that way. $2.5 million, that speed. Today, 10 years later, this year, you'll be able to go out and buy a 64-bit Game Boy from Nintendo for your kids for $250 that has the power of that Cray supercomputer. And your kids are carrying them around. Those kids have more computing power in their hand than most of the generals in the world command in their army. Think about it. Think about that in the curriculum and what's coming out of the way. Now, what could this mean in our industry? In the construction industry? But you know what's anything different about this machine? This is the concept of what I call a 5-wire machine. The whole machine is controlled by wires, steer by wire, brake by wire, air conditioning by wire. The only thing holding that cab on there is 4 bolts and a whole bunch of wires. If it's by wire or computer control, you can program the machine. You can program the machine to do whatever you want that machine to do. This is a 4-wheel drive, 4-wheel steer type machine. How do you want to steer that? Do you want just the front to steer? Just the back to steer? Both of them steer at the same time? Both of them steer in the same direction? Walk sideways, you load it, take it off. How do you want this to react here? You want to go this high and stop? Put it up there, hit the stop button. It'll program it to do what you want. You want it to lift level, take off the bucket, put on the forks, and you want it to lift level, hit level, lift, and do it. The concept is to be a very quiet machine. Noise is a food. Operators don't like it. Spectators don't like it. You don't like the machine there anymore. It's concepted to have different cooling systems on, to have different shapes on it. That was the future machine then. We actually built this machine. We actually built this machine. This machine is a machine you're not going to see in production. It's just a machine of ideas. This machine has been scrapped out now probably for 5 or 6 years. But a lot of the technology that went into developing this machine is in production today. This stuff is happening, and it's happening very, very fast. There's another trend that's going on in the world. And this is in the mining industry, and that is bigger. This is a man standing next to the biggest machine we make. This is what we're looking at, making a D12. That's a 90-yard D12. What that means is this blade on the front of that probably runs from about this high, probably over to here and down. That's a big blade. That's a wall. And that man's pushing it. Bigger is better. That's what's going on in the mining industry as far as technology. 793 truck, 240-ton truck, 830,000 pounds gross weight load. Almost 1 million pounds coming down the road at 50-some miles an hour and can stop overnight. Now, can those machines get bigger? Can those machines get big enough that all those fit inside of another truck? What's the weakest technological link to getting bigger in the future? Right now, the weakest technological link is the tires. Tires won't take it. The tires on these machines, 10 miles per hour of the tires will not take all of that technology that's going on. They will break. Bigger is better. Why is bigger is better in the mining industry? Why is that the trend? The reason is one man on that 785 truck can do the work of 5 men on a smaller truck. 1 man versus 5. Productivity per person goes up. The productivity of 1 man versus that 5. This is what's going on out there in the world. This is going to continue to go on. As these machines get larger and larger, all this productivity increases. Now, how big can they get? They can probably get as big as you want them to get. The problem we're having with these machines is they are getting so big, they are compacting the ground so tight when they go over them that you have to have bigger machines to make that ground level, to make that ground work, to make that ground smooth so that when they go over those tires don't get hurt. Those tires on those machines cost as much as a Cadillac. Every time you see one of those large trucks go by and you count 6 tires on them, that's 6 Cadillacs on each corner. Think about that. Think about that. Those tires on that are so expensive. They can't be keep this stuff running. The tires on these trucks are very, very fragile. 10 miles per hour, those tires will not take it. Very, very fragile. Another part of the concept of bigger is better that we're looking at is this 57 Chevy parked into the bucket of a 994 wheel. 994 weighs as much as the Statue of Liberty. 2,050 horsepower. Fact is, if you buy this machine, the dealer will throw in 57 Chevy. $1.75 million, I believe, is what this is going for. It's actually a service field. You drive it underneath the machine, put a 55-gallon drum in the box, back on, and change the oil. We talked about computers on these machines. They've been there for a number of years. Computers are really dumb until you tell them how smart they are. You get a computer home, it just sits there, it won't do nothing. You put the software in, you give it some input through the keyboard or through sensors like we do on these machines, and it becomes smart. There's a computer we have on there, it's a payload measurement system. It measures the weight of the material in the bucket and measures it on the go. It does this today. You can actually build the guy right from the cab. Put a printer in there, build the guy right from the cab. It gets its input into this from various sensors in the lift circuit and the pressure. We can telemetry that information right back to the office. Today you have to do some calibration on that. In the future, it will be self-calibrated. You hit a button, it'll go through an exercise, and it will calibrate itself without even waiting the button. Beyond that, it's going to auto-read zero. What we mean by that is it's going to weigh on the way up and it'll weigh on the way down. Now, why do you want to do that? In case it's something stuck in the bucket. You want to subtract that weight off. The object of this in the future is to make it so accurate you don't need scale houses. That's what we're trying to get with it. RF sensor. It's a sensor, another input into the computer that goes inside the cylinders. It's so accurate, we don't know how accurate it is because we can't find anything to measure as accurate as what it's telling us it is. A little expensive right now, but it's going in there, input into that computer. Not only does it tell the computer where it is or how long it is, but now the computer can tell it where to go to do things. Ways you don't, that's what we want to get it up to. You want to put so much on a truck, and you're a little shy, so you take that last bucket load, you go up, you want to dump it, you know how much it's going to go in there, you hit the bucket, and it'll automatically dump so much material in there until it gets up to the truck and full, back off, and you send it back and forth. We also have a system on there called ride control. It's very easy. Most of you probably drive around in pickup trucks that have ribbon in them. You know they ride really kind of rough if you don't have too much weight in the back. Put a little weight in the back of the pickup truck and it'll ride as good as you can. You overload it, now it's a little on the safe side. What this does is it's a big old spring right here, and it adjusts the lift arm so that operator gets a perfect ride no matter what. You are familiar with four-wheel drive ag tractors or any kind of four-wheel drive big vehicles like this. You get them torn down the road and they'll start loping. This smooths that out. Now, if we had something on that machine, we know how much that machine weighed, table monitor does that. If we had something on that machine, we knew what the weight of the material was in the bucket, table monitor does that. We should have that computer talk to this computer and adjust that spring so that that guy gets a perfect ride every time. And that, ladies and gentlemen, is the value of putting computers on machines. They talk to each other. Hundreds of times a second, they talk to each other. We don't. I'll guarantee you the biggest problem you have in your job right now is communication. Usually lack of or misinterpretation of or whatever. Hundreds of times a second, they talk to each other. Give you a perfect example in your own mind. Last time you were home, how much time did you spend talking to your wife or significant other? 20 minutes, maybe a day, maybe. How much time does each kid or grandkid get? 10 minutes a day, maybe per kid? Hundreds of times a second. That's the value of computers on these machines. Now, oxymoron. Anybody know what an oxymoron is? What? Different but the same. What an oxymoron is two words, usually two words, that have opposite meanings that you put together to form a new phrase. So they have opposite meanings to form a new phrase. Jumbo shrimp. Second best. You're in school. Student, teacher. A lot of people say military intelligence. Death, benefits. That don't go together at all. Civil war. I had one customer jump up one time and he says, happily married. Obviously. Tomorrow's machine are going to be an oxymoron. I'll get to this bucket. Tomorrow's machine are going to be simply complex. Now, what do I mean by simply complex? Anybody out there a photographer? Let's go back 20 years in this man's life. You want to take up photography for a hobby. So you go out and buy yourself a single lens reflex camera. Costs you for a good camera $500, $750. Get that camera home, you open up the box, and you pull out the camera, and you pull out this book that's about 3/4 of an inch thick. You got to read this book to figure out what all these digits, gadgets, and dials are in this camera. As you read this book, lo and behold, you need an exposure meter. So you go out and buy an exposure meter. It comes back with another book. You read on into the book, and you need a flash test. You go out and buy it. It's got a book that you got to figure out. You keep reading on in the book, and lo and behold, you need so much stuff that you got to go out and buy a big old bag and carry all of this stuff around you. Now you only got about $3,000 to $500 invested in your hobby, and maybe after 50 rolls of film, if you're good enough, you can take a pretty good picture. That was what, 15, 20 years ago. Today, what is it? Today, for about $125, $200, you can go out and buy what I call a point and hope camera. You get this camera home, you open up the box, you open up the instruction book, it's got about 3 pages. You open up the instruction book, and it tells you how to open the camera, where to put the film, and how to shut the camera. You do that, and what happens? As soon as you shut the back of the camera, it winds the film. It stops at picture number 1. It reads the barcode on the film as it goes by, so it knows what the film speed is. Comes time to take the picture, you point the camera, and you hold it. And it flashes if it has to. It winds on picture number 2, point and hold. Picture number 3, picture number 4, keeps winding on. Gets to the end of the film, what happens? It stops, winds all the way back to 0. Now all you gotta do is figure out how to open up the back of that camera. That's a very, very, very complex camera, but very simple to operate. Simply complex. Tomorrow's machines are going to become that. Very simple to operate, but very, very complex machines. The education that your students here are going to be put through with this electrohydraulics lab are going to start answering and teaching those how to handle these complex machines. Why is this going on? The reason they have to be simply complex, point and pull, is because there's a trend going on in the world of which your kids and grandkids are all a part of, and that's this. Today's kids don't play in the dirt. Think about that. Think about that outside the box. They don't play in the dirt. When I grew up, I played in the dirt. When half the people in here grew up, we played in the dirt. That's about all we had was dirt. Today, they might play in the dirt when they're 2, 2.5, 3, 3.5, 4. I don't think so. Comes about 4 years old, what are they doing? They're in playing Nintendo. They're playing Atari. They're playing Sega Genesis. They're beating on computers. They're like this little gentleman here. When they grow up and become adults and go out into the workforce, guess what? They're not going to want to go out and work in the dirt. Guess what our equipment does? It works in the dirt. The trend that we're having is becoming harder and harder to find good operators. When I grew up, this was me. Those yellow machines went by, and my reaction was this. Wow, I want to get on that thing. I want to learn how to drive that thing. These kids don't. These kids don't. It's becoming harder and harder to find and keep good operators. Point and pull. As scary as that sounds, the kids today would rather play in the dirt than they would in grease and oil. So as hard as it is to find good operators, it's going to become harder to find good service technicians. That's the value of this school. That is a tremendous value that this school has for this part of the industry. Very, very important. Now, let's talk about the operators tomorrow. Anybody got an idea what this gentleman's doing here? I might see a little bit of this afternoon. What this gentleman's doing, this is down at the University of Illinois, he's actually designing the cab. He's designing the controls of this machine, but there's no machine there. This is virtual reality. He sees everything to his right and his left in 3D through these glasses. You can see the sensor on his head, the wire running down his back here. This is all hooked up into the computer. All the steering wheel, all the controls are hooked up to the computer. As he runs this thing, the whole scenery changes based on where he is looking. He sees that in 3D. So he can go up and we can design this cab in virtual reality inside this cage, inside this box, and never cut iron. That works out really good because it's expensive to cut and weld iron. And then when you sit down in the cab and you screw it up, you gotta go back and recut the iron. It's a lot easier just to go over, be on the computer keys, and lower that wall down in the cab, or change the controls. Virtual reality. We'll see a demonstration of that this afternoon. Let's talk about tomorrow's cabs. Now, your opinions mean nothing because you're not going to be in these cabs. But your kids and your grandkids are going to be in these cabs. So knowing that and knowing them, what's the number one thing you have to have in these cabs? Stereo. Somebody said stereo. You're going to have a really good radio in these cabs. Now remember, they don't want to be there anyhow, so you better have stereo in them. What's number two? Air conditioning. Right. They don't want to be there, so you better have a good stereo and a good air conditioning. You probably need a microwave, you probably need a refrigerator. What's number three? Video games. Think about it. Video games. Everybody says you're crazy. We want to put video games in there. They don't want to be there anyhow. You better entertain them. Ever watch your kids or grandkids at a video arcade? Or maybe some of you at a video arcade? What are you trying to do? You're trying to beat somebody's score, right? You're trying to get your name one notch higher. And your kids will put in quarter after quarter, 50 cent after 50 cent, trying to raise their name one notch higher on that scoreboard. Take that same concept and put it in the machines of the future. Here's 2005. I just come out with this new machine. It will load 1 million tons per hour. Nobody in the whole world has ever loaded 1 million tons per hour. Old Van Over's feet, he got up to 900,000 tons per hour. That's on your job site with Susan. Can you get Susan today? What do you think of video games? Think about it. Tomorrow's operators, workforce 2,000, minorities, females, immigrants, all have to fit into this cab, no matter what size. Female operators. We're talking about contractors out here about federal advantage kind of hurt your ego a little bit. Female operators are much better than male operators. Much better. They finesse the machine. We manhandle. They finesse. They've been finessing us for years. They do the same thing on that road. They are very good, very smooth operators. Number one, they will read you the operator's manual. We don't. We already know how to run, right? We just get in and go. Very, very good operators. Yet their requirements in that cab are a lot different for them. There's another cab. Why won't this cab work for tomorrow's operators? Right here, 2 levers. Name me one video game that's got 2 levers. There isn't it. Kids won't know how to run this machine. How do they play these games? Joysticks? With their thumbs? Can you run these machines with your thumbs? You bet. If you've got some kind of electro-X control, which means you have something in your hand and a wire coming from it that controls the engine and hydraulics, what does that look like and where do you put it? Questions for tomorrow's cab. Who's the smartest doctor in the world? Everybody usually says the working. Smartest doctor in the world has got to be a veterinarian. Why? He works on things with 2 legs and 2 arms. It may have 2 legs, no arms. It may have wings, whatever. It may have 4 legs and a tail, horns. Or it may have no legs at all. And the worst part of it is that when his patients come to see him, the patients can't tell him where they hurt. That's why he is so smart. He's got to analyze, diagnose all this stuff. The problem we have with that is tomorrow's servicemen have to be as smart, and technicians have to be as smart as the veterinarians. Customers call up and say, I got this machine out there. It's not running right. Well, what's the matter with it? I don't know. It's not running right. Come on out and fix it. Well, he gets out there and it's got wheels on it, it's got track on it, it's got this engine in it, that engine in it, that hydraulic system, that hydraulic system, this electrical system. And when he gets there, unless it's got pieces laying on the ground, the machines can't tell him where they hurt. That's why they have to have a good education to get those smart to start analyzing this, the diagnosis. Today's machines do tell you where they hurt. They're starting it, all these sensors on these machines to these computers. Your machine, you got sensors all over your body running through your central processing unit up here in the morning. These machines are getting more and more sensors on. They have the ability to tell them, the mechanic, where they hurt. They will tell you where they hurt. They will remember where they hurt yesterday because they might not hurt there today. Computers all that memory. Not only that, they will tell you who hurt them. Think about that if you're an operator. They all got real-time clocks on them. Yesterday at 10:02, my man was over bed for 30 minutes. Gosh, who was on that? Oh, Clem was on that yesterday. We better go talk to Clem about his operators. They do that. Your cars today do that. Take them into the shop, they just wouldn't plug them into a computer, sit down on your seat, turn on your radio, download all the fault codes through your radio. Diagnose what's going on that machine. What's all this going to mean? What's all this electronics mean for us in the future? Anybody in here buy a VCR 20 years ago? 15 years ago? Let's pay for it. Too much? Good answer. Honest man. Probably $750 to $1,200. You go back 15 years, buy this VCR, it costs you at least that much. It's as big as a suitcase, top loaded. You get it home, you open up the box, plug everything in on it, it records, it pauses, it goes forward, goes backwards, plays movies, flashes 12 a lot. And that's about it. That's about it. It costs $1,200. Today you want to buy that VCR, you go out and spend about $250 for that VCR. It's about a third the size it was then. It does 10 times more than that one did. It does it 10 times better. In fact, these VCRs today do so much you don't know how to make them do everything that they do. And it does it from across the room. Think about that. That's what this graph is trying to show here about electronics and computers on these machines. We're sitting here today. This is just positive here. This is time across the bottom. What does this computer cost today? Just like that VCR. Today they cost a lot. Tomorrow, that cost is going to come down. Customers. How many customers are willing to buy those VCRs back then? Just a few. How many in here today don't own a VCR? Camcorders count as VCR. How many don't own it? One person. How many own two? How many own five? That one man back. 12 is the record, but that back when I owned the shop. You look at this. Back then it cost so much, today it's down here. Customers, how many customers of VCR was there back then? Today, everybody in here, except one person, owns at least one of these. What did it do back then? Not too much. Today, not so much, we don't know how to make it. Right now, we're at this in time. The computers are on the big machine, the expensive ones. $1.75 million, $994. I can hide a $30,000 computer in a $1.75 million machine. I can't hide a $30,000 computer on a $600,000 or a $60,000 machine. That's kind of tough. But the little machines have got the numbers. They have got the numbers. That's what will bring the cost down. How far are we from this? We're here today. We're here today on the larger machines. We have something called VIMS, Vital Information Management System. It's a big computer. It gets all its input from various engine computers, transmission computers. The information all travels down a multiplex highway into the main computer. In that main computer is diagnosed, and it's a management system. It's a maintenance system. It's all hooked up into the control panels, into the warning system of the machine, so it can tell you when it needs service, when it hurts. It's hooked up into various management systems, payload control system, so you can get productivity of the machine, and when the person comes to it, hooked into a service light, and when the mechanic comes to this machine, he will bring his number one tool with him to talk to that machine, and it's not a 3A socket, it's a laptop computer. That's how they talk to these machines. Walk up, plug in, download all the information. Okay, let's take this and start wrapping it up. We've got this scenario here. We have this truck, and it wakes up one morning, and it don't feel good. It's not busted, it's just sick, it doesn't feel good. So what do you do when you don't feel good? You call the doctor, right? The machine, it gets on the telephone down here in South America, and it calls the doc. Doc's up here in Aurora. Doc says, what's your exhaust temperature? What's your boost pressure? What's this? What's that? Starts asking this machine all kinds of questions. Takes all this information, runs it through the computers, through some kind of artificial intelligence means, some kind of database. Gets on there, analyzes it, maybe asks it some more questions, and says, I think you've got a turbo problem. So the doc gets back on the telephone and he calls the dealer down here in South America. The dealer picks up the phone and he says, hey, you got a machine down there, serial number TPM 60538. It's got a bad turbocharger. So the dealer looks at that and says, oh, that belongs to, what's your name? Mark. That belongs to Mark.
I better go talk to Mark. Now, Mark, wouldn't you be impressed if you would have walked up and said, "Hi, Mark, how you doing today? By the way, your truck called me up this morning, and it don't feel good." When in the next 50 hours, at your convenience, can we come out and swap that turbo? That'd be impressive, right? Let me ask you a serious question. On this scenario, what's the hardest thing to do? The hardest thing to do is put that satellite up. It's there. It's there. What's the second hardest thing to do? Second hardest thing to do is put these dishes on Pat and Peter. They're there. They're there. The only thing missing is this link with that truck. It's coming out. It's coming. Stop thinking about this. If that truck was built on a computer-controlled assembly line, it is. The computer at the end of that assembly line can talk to the computer on the truck and tell it the part number of every part it's got on it. If it knows the part number of that turbocharger, why doesn't that truck get on that same telephone and order the part? It can do that. If that truck had a credit card or a unique number, like a serial number, which it does, it can pay for that part or charge. Think about that. Think about that in your business. How that could affect your business. If that is the case, that truck can get on that same telephone, call the manufacturer who makes turbochargers, say, "Hey, I'm ordering a turbocharger, part number from parts. Put a new one on the assembly line today to replace that one." You'd never run out of parts. This stuff's coming. How far is this in the future? The future is here today on technologies like this. Today we have a system we're starting with called APS, Advanced Product Services. We're monitoring several hundred on and off highway trucks and their engines from a computer in Peoria. We use GPS satellites, global positioning satellites to tell us where in the world the equipment is. We use information satellites to download all the information. It just comes in on a trend line. If you look at that line, you look at that graph, give you a true case. Doc comes into her computer one morning, she sits down, she says, "Let's see how my patients are doing." So she dials up all the information from the satellites the night before. Got this truck down in Texas that the fuel pressure started to rise up on. She starts investigating a little bit, she finds out that he filled up with fuel down there, because here he's empty, here's full. So he knows he's down in Texas and he knows he filled up with fuel. So he's watching this and it just keeps the pressure keeps going. So the doc pushes a button on her console, it turns the light on the dash of the truck down in Texas. Now all that means to the truck driver is phone home, Doc wants to talk to you. So he goes outside the road, the phone booth, calls up Doc. Says, "What's the matter, Doc?" She says, "You picked up a bad load of fuel down there in Texas, the fuel pressure is going up, you're going to have problems." She says, "No, it's running good, it's running okay, there's nothing wrong." She says, no, it looks bad." She says, "No, it's running good." She says, "I don't care. You picked up a bad load of fuel down there, you were right here. Here is where the dealer is, he's 60 miles up the road, I've already called the dealer, he's got a filter, he's got the fuel to get you in and out of there in 20 minutes. I said, "Oh, okay." Before he got there, the truck was starting to mix. The doc in Peoria knew about it before the truck driver did down in Texas. So this stuff is coming fast. Now, talk a little bit about GPS, global positioning system. Any of you guys are hunters or fishermen out there, you probably have your own little unit. The Ranger is into this. It's a navigation system. There's a bunch of satellites that are up there that tell you where in the world you are, kind of a triangulation type thing. It'll tell you where you are, and it will tell you where you are, X, Y, and Z, longitude, latitude, and altitude. The more expensive units you get, the bigger or the narrower it is, the more accurate it is. If you look at any kind of construction job, no matter what it is, all they do is longitude, latitude, and altitude. X, Y, and Z, cuts, fills, whatever, where in the world are you? So we're taking this and we're starting to apply it into this industry. Now this next scene is going to take a little bit of explanation, and it takes a little fast. It happens fast. A compactor is a machine that runs around and compacts the dirt. You make a building or something like that, a football field. And all it does is it runs over this area and it tramps it down, compacts the soil. Now, we'll stop this in here about right in here somewhere. What it is this might be, let's say, a football field, whatever it is, soccer field. And your job is, as an operator, is to run over this area. And you have to go over it 4 times. Because the state inspector is going to come around, he's going to check the compaction. So you get in there and you start driving over this field, you go over it 4 times. How do you know you've been over it 4 times? You don't, you're taking a guess. You might go over it 6 times, but when the inspector comes out and inspects it, you know where he's going to inspect it. He's going to inspect it where you only went over it 2 times. So what this is a screen inside of that cab in there with that operator. He's just watching the screen. And it's set off in some kind of area, this being the football field. As he drives this machine over this area, it's kind of hard to see, but that is white. The next pass as he's backing up is green. The next pass will be blue. The next pass will be red. So now you just go to the operator and you say, drive over this area until that whole screen is red. And he knows he's been over 4 times. Save you fuel, save him time. And the state inspectors I talked to said, we can monitor this on the satellite just like you're monitoring it. And we'll say that's proof of the job well done. We don't have to send you down out to inspect it. It's wonderful. There's another system, GPS. You can use GPS, put it in your pickup truck, put it on your bulldozer, put it on your motorcycle, your Land Rover, whatever. You can survey it. You go out and you get the longitude, latitude, and altitude of it. Take it all back and you put it into a computer and you say you want to build the same football field. Well, what this is, the red is cut. It has to be removed. The blue is filled. It has to send that from there over to the blue area. And the white is the gray. You take this monitor and you put it on the cab, and you can't do. This is that bulldozer, top blue coming down. GPS is right here on that bulldozer blade. This blue line right along here, that is where you want that dirt to be. That's the grade. Here's the blade. Now, once he gets down there and raises that blade, he'll turn that to white. He's putting that to grade. So now all you do with the operator, you don't need any grade stakes, any surveying, you've done it all out there. You just go in and you say, okay, here's this red material. Take that red material, push it to the blue area until this whole thing is white. And here's your line. That's the grade. Now, what have I showed you? A video game. Think about it. It's a video game. The only thing missing is a little score pad up here that says, hey, you got 10,000 cubic meters of material there. Let's see how fast you can move the 10,000 cubic meters from there over to here. No. Video games. They're here. Another video game. This is in gold mines. In gold mines, there's good ore, bad ore, and ore we have to get out of there, but we can't make money on. We'll go stockpile. Or there's my ore, there's your ore, and there's your ore, and you're claiming we want to make sure we get the money from our ore in our pocket. So they go out and they survey all this, and then they blast it and they pull their survey stakes up. So they don't know where they live. But this is GPS on this loader, and it's hooked right to the bucket, and it talks to the payload measurement system. So that every time he gets a load of ore out of there, it knows where he got it. It knows how much it weighed, and you can even record what truck it went out on. Very, very important information for the people using it. The customers who are experimenting with this say it will save them $1 million per year per machine. Now that's a good video game. Let's take this and start wrapping it up. Let's say we want to build a road, we want to build a mine. So we go out and use aerial survey, we use GPS, and we survey this area here. We take all of this topography information, take it back, digitize it, put it in a computer, put it on a plan, give it to a man, and go out and we build the road. We're also working on ground penetrating radar. That means when you fly over this, not only do you survey the ground, but you survey what's below the ground, because there might be rocks down there, pipes down there, this kind of material, that kind of material. Very important information. You take all that information back, put it in that computer, put it on a plan, give it to a man, and say, go out and build the road. What we've been talking about here is total computer-controlled machines. We're talking about computer-controlled engine modules. They're there today. EUI engines. Every one of your cars, probably every one of your cars, got a computer-controlled engine. Transmission module. Most of the stuff we have today has transmissions in it. Automatic transmissions in it. Computer-controlled transmission. Implement control. Electro-hydraulic implement. Your new lab over here. Electro-hydraulics. Computer-controlled implement circuits. Computer-controlled pumps. RF sensors, more input into that computer to tell the computer where the cylinder is or where you want it to go. Wheel slip. You have it in your car today, traction aid, anti-lock brakes in reverse, computer control. That's on the machines out there today. Smart pumps. There's these pumps with computer chips in them. Tell them what you want to do. Pump this, pump that, do this pressure, this flow, whatever it is. They're there today. Radio module. Today in the military, they use not scrambled communication. I got a transmitter and receiver, he's got a transmitter and receiver, and we just talk to each other. And we're all over the frequency spectrum, and nobody can follow us that fast. That's why we don't have to scramble. You two can have a transmitter and receiver, you talk to each other, we talk to each other, and you don't interfere with us, and we don't interfere with you. You take that same transmitter, that same technology, you put the transmitter in the hands of the operator, you put the receiver down here on the engine, transmission, implement control, and now what you have is a radio-controlled machine. What you've just done is now you just cut all the wires from that cab. Now, the only thing holding that cab on there is 4 volts. So where do you want the cab? You want it on the machine? You want it off the machine? You want it up in some nice air-conditioned pedestal? You want that guy running more than one machine at the same time? Well, what we're talking about here is how these computers talk to each other. If they talk to each other so good, why don't we just look at this design computer, take the disk out of this computer, go over to all the machines, load the information into the machines, go up on the block, say, gentlemen, start your engines. They all fire up. They go out, and they build the road, or they build the mine, and nobody is on the machines. Might be a scenario that looks a little something like this. Got this computer, it's a mine computer, mine scenario. Here's the topography of the mine, here's the road, here's the pit. Now this is a total computer controlled mine. Now the loader down here, the trucks are running up here. Now these are autonomous trucks. There's nobody driving these trucks. Therefore they can look a little different. They don't have to have a cab on. Put duals up here, carry more payload. We got to be able to detect obstacles since we're in the road that weren't there the last time. Warn the people back up in headquarters, be smart enough to find their way around that rock and go on up with their work. They got to pass other high-speed vehicles, 1 million pounds one way, 1 million pounds the other way. They got to be accurate enough to do that. They got to find these dump sites, and they got to be accurate enough to do this, because a lot of these are on the edge of the mountains. And you want to dump the load over the edge, you don't want to dump the truck over the edge. There'll be other autonomous vehicles running up and down these roads. What makes you think that loader down in the pit has to have a man on it? It just has to have the ability to see, sensory perception, and we're working on all that. Maintenance, service, it'll schedule its own maintenance, its own service. It knows how it feels. It's probably monitoring its own oil pressure, it's monitoring its own oil, it's doing everything in there. It knows how it feels. Now it's got to be able to negotiate these mountain passes, and it's got to do it accurately. And it's got to do it accurately whether it's rain, sleet, snow, or whatever. Now this is future technology. How far in the future? Future is here today. Just up the road here, Kanaka Hills, and this truck is running. This truck is using GPS and radar on it for navigation. This truck is running autonomously. There's nobody driving that truck. We have 2 trucks down in Texas in an aggregate quarry down there running autonomously. Nobody is driving those trucks. Those trucks are running side by side with each other. They're running side by side with trucks with people in them. We talked about accuracy, backing up to that truck. I don't think a man could back that up that fast and dump that over. By the way, on the other side of here, we see is a 250-foot drop off. If you're riding in that truck and it backs up, you're scared. You want to hold it that. Because then it has to find obstacles in the road. Warn the obstacles. Or tell them, now is this little guy happy that truck stopped? You bet. We're working on auto-dig excavators. You take them to where you want them to dig, you tell them how deep you want them to dig, you get the dig and get off. And let it go dig. It's got to be smart enough, these are smart enough to find their way around rocks. It's down there digging a trench and encounters the rocks. It's got to be smart enough to figure out how to go around. You look at an excavator here, and it's just half of that little backhoe loader we talked about. It's got the same front end on this as that loader had for a rear end. So the same technology that works on the bigger machines, the bigger excavators, will work on the smaller machines. Slope control, the same thing. You dial it in the computer, tell it what slope you want to cut. You pull one lever, and that machine will cut that slope to an accuracy of within a half an inch in about 50 feet. Very, very accurate. As you can see, CAD is thinking far out into the future. With your help and the help of the dealers, we can all set new standards that would have been unheard of just a few short years ago. If you're looking for me, I'll be a CAD, where we're always looking out for the future. I hope that gives you a little bit of insight into the future, and thank you for your attention.
I wish to thank Tom very much for his presentation this morning. I saw his presentation about 2.5 years ago, and when he talks about the future is now, it's moved a great deal since the time that I saw it 2.5 years ago. And I think all of us, when we look at technology, electronics, when we look at the computer, regardless of where we are, we can put ourselves in that type of situation, whether it's with that camera, or whether it's in the automobile or someplace else. By the way, Tom, I have a lot of times I see those automobiles coming down the road with nobody driving. So, what we want to do is take about a 15-minute break so that you could get your coffee cup and get a soft drink. There are some restrooms to my right here, and then out in let's see, that would be the northeast corner of the first floor. But we can take about a 15-minute break at the back. Then we're going to have a short program to dedicate phase 2 of the Noble Center for Advanced Technology. And then following that, we might gain just a little bit of time because we will have some demonstrations that will display or portray the type of technology that we're dealing with at OSU Okmulgee in the various rooms. And so we want to provide you with the opportunity to get in there and visit with some of the people that are providing those demonstrations and see the kinds of technology that we're dealing with as we attempt to prepare people for the world of work that's emerging, particularly for the 21st century. So we take 15 minutes and come back and we'll start. Thank you. The next part of our program deals with the recognition and dedication of phase 2 of the Noble Center for Advancing Technology. And the door in front of me used to be, until the phase 2 was finished, was the entrance to the Noble Center. So we built on that way, and we built on to the door an additional 40,000 square feet of space. And so to preside over the dedication of phase 2 of the Noble Center for Advancing Technology, Dr. Margaret Keener, the Executive Vice President of Oklahoma State University, is with us this morning, and I'm very pleased to introduce to you Dr. Keener.
Good morning. This is a wonderful day in the history of Oklahoma State University at Okmulgee. This is the occasion, as Bob said, that we're going to dedicate phase 2 of this center. Houses a lot of things, electronics, robotics, has a two-way video and multimedia classroom capable of sending or receiving specialized courses to enhance the student experience. It also houses the computer integrated manufacturing center, in which design and making of a part is accomplished via automation from start to finish and utilizing computer connectivity. This really affects, in a very fundamental way, the lives of the students of this university. For example, just this past year, I believe, we had 8 students that participated in an internship at Concurrent Technologies Corporation. This corporation typically hires interns from Harvard or Caltech or Carnegie Mellon, someplace like that. This year, for the first time, they took interns from OSU Okmulgee. And this is the only school that gives associate degree programs that this corporation would take any students from. And after they did that, had a little debriefing session with Bob. Bob tells me that they told him these were the best students. So they want more. So we're going to have more for next year. Clearly this is an example, this facility is an example of bringing dreams to life. And speaking of dreams, phase 2 was a dream 10 years ago when phase 1 was done. And today we have 2 legislators on the stage with us that are directly responsible for bringing this particular dream to life. I'd like to introduce these people and ask you to hold their applause till we have them both standing. But first of all, Representative M.C. Least is here. You'll remain standing there. Representative Least was instrumental in developing the support in the House for the Hero Bond issue that provided the major part of the funding for it. We also have Senator Frank Schertz, who is responsible for developing the support within the Senate for that bond issue. And I'd like for us to take a few moments to express our appreciation with applause. He couldn't be here today, but I'd also like to take a few moments to thank Speaker Glenn Johnson. It was his ability to provide that leadership. It's a major reason why such a facility can be built. Our speaker today is Dr. Kermit McMurray. Dr. McMurray began his post-secondary educational experience at Crowley County Community College in Arkansas City, Arkansas. Later, he got his MS and BS from the University of Colorado and his PhD from the University of Nebraska. In 1990, he joined the Oklahoma State Regents for Higher Education as the Associate Vice Chancellor for Academic Affairs. And just recently, I believe in June, was promoted, to Vice Chancellor for Student Affairs. Would you join me in welcoming Dr. McMurray?
You know, technology is often characterized as the engine of economic growth as we move rapidly into the 21st century. Clearly, the economic future of Oklahoma and this nation depends in large measure on our capacity not only to invent, master, and harness this new technology, but to use these tools to promote greater prosperity for all of mankind. Good morning to each of you individually as well as collectively. It is indeed a privilege for me to be here this morning. I want you to know that there's no better place that I'd really rather be than on OSU Okmulgee campus. There's something about being here that is exciting. There's electricity in the air, and I guess as my kids would say, OSU Okmulgee has got it going on. And so I want to recognize this great student for what it is doing. Thank you too, Mark, for the very kind and most generous introduction. I also want to take a moment to acknowledge the members of the various advisory committees who are here. Would you please raise your hand? I think it's important for us to know who you are and to say to you, thank you for the contributions that you have made to OSU Okmulgee. You know, Provost Collins indicated I only had about 10 minutes, and I told him if it was okay with him, I'd really like to stay up here for 10, 20, 30, 40, 50 minutes. And I came with a presentation that will take at least several days, and if you bear with me, I can reduce it down to a half a day. Hopefully we meet out here by the time we get ready for lunch. No, It is indeed, though, my pleasure to stand before you this morning in collective celebration of this noteworthy event. The expansion of the Noble Center for the Advancing Technology clearly raises the bar in terms of the quality of education students receive here at OSU Okmulgee. As Marvin has already mentioned, there are many persons involved who have made this moment possible. But in particular, I think it is important that Senator Frank Sheridan, certainly Representative MC Lease, and while Speaker Lane Johnson is not here, that we specifically recognize them once again for the work that they have done to make this possible. I think it's also important that we recognize the legislature, and equally as important, Oklahoma taxpayers for their willingness to invest in higher education, as well as the future of Oklahoma students. I think it is also important to note that Oklahoma State University at Okmulgee is an essential part of the Oklahoma State system. As one of our three campuses in the OSU system, OSU Okmulgee is unique in its role and mission as a high-quality technical institution. Under the dynamic leadership of Provost Klabenes, this institution has demonstrated an unyielding commitment to raise the level of preparation for its students by developing high-quality academic programs consistent with emerging educational labor market needs, recruiting an instructional faculty that is second to none, hands-on approach to teaching has been recognized not only in Oklahoma, but also across this great country. Add to this equation state-of-the-art equipment and facilities and strong industrial partnership clearly positions Oklahoma State University Okmulgee as a world-class center of intellectual and technically advanced hands-on learning. The state regents, along with the chancellor and staff, are proud of what this institution has accomplished over the past decades and clearly embrace its unique role and mission. As I contemplate how I might describe the impact of technology on our lives, I immediately realized that to describe advancing technology is analogous to attempting to describe life itself. In many ways, as life is dynamic, so too is technology and our perception of it. Advancements made in technology has changed the way we live, the way we learn, and of course, the way we do business. On my flight to Oklahoma City last evening, it was called to my attention, as we also learned this morning, that recent advancements in technology makes it possible to accurately pinpoint our arrival time. State-of-the-art technology called differential global positioning systems allows pilots, surveyors, and others using satellite positioning information for civil use to determine their position on Earth to within a few meters or even a few centimeters. So when we boarded that plane last night, we benefited from this extraordinarily useful technology that improves travel safety. Whether in the air, on land, on water, when our military defends our national interests, it uses differential global positioning system technology to establish their position with pinpoint accuracy. Differential global positioning technology will be the tool that drives the intellectual vehicle highway system for in-car navigation and commercial vehicle routing and scheduling. Add to that, the assistive technology is increasing the quality of life for the physically challenged or those immobilized as a result of an accidental misfortune. This technology has either maintained, increased, or improved the productivity of their lives in ways never envisioned 20 years ago. In the way we learn, advancements made in technology has improved the quality of education as well as increased our access to it. Thanks to technology, it is now possible for K-12 classrooms to interact with other K-12 classrooms around the globe. Additionally, computer-assisted instruction provides students with an alternative to traditional classroom settings by freeing instructors from rote processes that are better handled by computers. pictures, sound, and video, as well as standard text. Using these various reference-based educational software has proven effective, particularly in meeting the heterogeneous learning styles of our nation's youth. In higher education, recent technological advances now make it possible for researchers across the globe to share ideas and theories as they strive to find the cure for diseases like AIDS or cancer. Advanced technology has increased access to post-secondary education by making it possible for many to have access to higher education coursework that might not otherwise participate in the traditional campus-based classroom. Whether getting specific work-related training, pursuing a degree, individuals are improving and or upgrading their intellectual skills and abilities right now by satellite, cable, and computer communications in classrooms without walls throughout the nation, and even in Oklahoma. Through this enormous technology, students' lives are enriched, access to education programs enhanced, and their intellectual productivity improved. In the way we do business, technological changes occurring in telecommunications, computer applications, advanced manufacturing technology, and service delivery systems are influencing demand for labor and the distribution of America's labor force. Most economic and educational planners agree that the workplace of the future will be technologically intensive. As technology continues to penetrate our very existence, so too does the need for a well-trained workforce. In many ways, our economic prosperity nationally and even in Oklahoma will depend on our ability to train a workforce capable of making a difference in the technological landscape of this country. Clearly, Oklahoma State University of Okmulgee is playing a major role in preparing tomorrow's workforce today. And this institution and its leader is to be congratulated for an outstanding job, not only now, but as we move rapidly into the 21st century. Thank you very much, and I've enjoyed being with you this morning.
Providing a student perspective is Mr. Paul Vogel. Paul is an engineering graphics technology student from Morris, Oklahoma. He is a member of Phi Theta Kappa, and while I cannot legally tell you what his GPA is, let me just say that if you have to look real hard on his transcript to find a grade other than A. Please join me in welcoming Mr. Vogel.
Good morning. My name is Paul Vogel, and I'm a student here at OSU Okmulgee. On behalf of Phi Theta Kappa, as well as the entire student body of OSU Okmulgee, I welcome all of you to this very important event. I would also like to extend a very special welcome to our legislative delegates who are present, Senator Frank Sheridan and Representative M.C. Least. I personally welcome. There is a time to dream, a time to recall, and a time to continue. The dreams of higher education have brought us to where we are. Looking back, we can see the many goals that have been achieved. So then, we must continue to dream and grow, lest we become stagnant. History has brought us here and set us on the road to the future. With the dawning of the 21st century, many challenges lie ahead. Higher education must prepare students to meet the 21st century. Students must be able to mold the 21st century inasmuch as it will mold them. Higher education must continue to heighten education as students meet and discover the living world of new technology. OSU Okmulgee is playing its part in the education continuum. We are fortunate to have a dedicated faculty, excellent equipment, and outstanding facilities. A prime example of our outstanding facilities is the Noble Center for Advancing Technology. The Noble Center is the epitome of an educational environment. The Noble Center was built in 2 phases. Phase 1 was completed in the mid-1980s with funds from the Noble Foundation. 40,000 square feet of new and modern space. The second was completed last year, adding an extraordinary 40,000 square feet. Unlike Phase 1, Phase 2 was funded by Oklahoma taxpayers using hero bond money. This is tax money at work. Senator Frank Scherr, Representative M.C. Lees, and Speaker Glenn D. Johnson were among the legislative delegates providing key leadership for the hero fund. A deep appreciation is warranted, for Phase 2 would not have been possible without the hero fund. The students, faculty, and staff appreciate the high quality of classroom and laboratory space found in the Noble Center for Advancing Technology. I invite everyone to tour the Noble Center. Feel free to take classes or attend any seminars in the building, and look forward to the two-way interactive studio, which will be open very soon. I encourage all to accept the challenges that lie ahead. Education is a never-ending process. Working together, we will continue to advance the education of higher learning. With one hand firmly grasping on the knowledge we have, and the other reaching for the knowledge yet to come, we can embrace the challenges of the 21st century. Thank you.
Providing the faculty perspective is Dr. Kurt Brewer, who is this year the chair of the Faculty and Staff Council. He is a member of the English faculty and uses a variety of multimedia techniques in the delivery of his instruction. Please join me in welcoming Dr. Brewer.
Thank you, Dr. Keener. And you didn't know how future-looking you are. It's Mr. Brewer. I do not have a doctorate yet, but sometime in the future we will have that. So you are very future-oriented there. Dr. Keener, Dr. McMurray, Mr. Vogel, faculty, staff, distinguished guests. It really is my pleasure to be here this morning and to speak at this event as a representative of the faculty of OSU Okmulgee. I take great pleasure in being here. My students take great pleasure in my being here because otherwise I'd be in class right now and they'd be giving speeches. So I'm coming over here and they get to work on their speeches, which are going to be Wednesday. So we've made everyone happy by my being here today. As chair of the OSU Okmulgee Faculty Staff Council, I am privileged to be able to represent the interests of the faculty and staff of this fine institution. And while I would never claim to speak for all faculty, I believe I can give a response to this occasion that's genuine and a fair estimation of, well, much of the faculty field. As I stand here in this building that's dedicated to educating today's students to meet the technological challenges of tomorrow, I can't help but be reminded of what a vital role technology has played in shaping the lives of everyone in this room. In fact, this morning, as I was thinking about what I wanted to say and how I wanted to say it, I was trying to think about how technology has changed our lives. And I sat down in front of my computer, drinking a cup of cappuccino that I got from the cappuccino machine at Get and Go, in a centrally heated room. And I had driven up to work in my automobile. And interestingly enough, I thought, well, it's not that difficult to see how technology has changed our lives. It's all around us. In fact, most of us have probably used technology a dozen times or more in the first half hour of our day and haven't even thought about it. And that's how it is with most of us. We don't really pay all that much attention to technology. But thankfully, institutions such as OSU Okmulgee, organizations such as the Noble Foundation, legislators and congressmen and senators, as we have on the stage here today, do take into account how technology will affect our future. They're not that cavalier about technology or about the future as we are every day. Just as pioneers like Benjamin Franklin, Thomas Edison, Henry Ford, more recently Stephen Jobs, Bill Gates, they've changed the way that we live and conduct business. So has this institution and this building right here changed the way that we educate. We are commemorating 50 years of OSU Okmulgee this weekend, and in fact, over the next year or so. And if there's one word that could describe the past half century, it is change. Not just change for change's sake, but change in an effort to continually shape and reshape the institution to meet the challenges of an ever-changing workplace that our students must face. The Noble Center for Advancing Technology, which we're dedicating today, is a key element in that change. In this building are housed numerous computer labs, lecture rooms upstairs with the computers and the latest presentation software. We have electro-hydraulics, robotics, the Technology Resource Center. Right to your right here is a classroom equipped to transmit classes to remote sites that are hundreds of miles away. This building stands as an icon of the changing face of education and technology. Personally, I've been at OSU Okmulgee since 1991, and in that short time I've seen numerous changes, all driven by the need to meet the demands of employers and the needs of our students. When I was hired, as a matter of fact, I had very little computer experience. That was something that I had wished that I had pursued more when I was a student, and something that concerned me about my ability to get a job in the future. And I had very little, and I did have a personal computer though. It was state-of-the-art at that time. It was an Apple IIe with a green screen and no hard drive, and I didn't have a printer, but I was up to the minute at that point, and I got it for free from my brother, so it was really good. But I didn't have a personal computer, and I remember talking to Dr. Klabenes, and I remember his asking me what I thought about using the computers in the classroom. And of course I said, well, I think they're wonderful, because I know that's what he wanted to hear, and I wanted a job, so I said, I think they're wonderful, and I'm ready and willing to do it. And that first year we opened a writing studio, which was a computerized classroom, a new thing for the English faculty, and I was one of the first ones to jump in and begin using it. And I found out that I do think it's wonderful. I've used computers and technology in many ways. We have the writing studio. We've opened up another writing studio since then. I'm in charge of the Skills Center, which is a computerized lab that's over in part of the library right now, and eventually part of the new addition to that facility. So computers and technology have changed. And from the aspect of an instructor, technology has changed how I teach as well. The classroom is now much more learner-based instead of teacher-based. I'm not those who speak and teach in a computer classroom are not the know-all of everything. We are much more focused on the learner. Learning is more collaborative, more flexible, more open. And these changes are not always easy to make or easy to get comfortable with. They sometimes mean rethinking our approach to teaching and to learning. And the second phase of the Noble Center here is another step in that process of changing to meet the technological demands of tomorrow. As faculty members, we welcome the changes, usually, and although they may sometimes cause us to move from our personal comfort zone, we know they really are for the best. In closing, I'm reminded of how we must continue to look forward in order to make true progress. It really has always been that way. I'm reminded of a story many years ago. A bishop was visiting a friend of his who was a college president, and they were having dinner and they were talking about the future. What does the future hold? And the college president asked the bishop, he said, what do you think lies in the future for us? And the bishop said, well, I'm firmly convinced the end of the world is soon to come, because man has discovered all there is to discover. We've invented all there is to invent. There's nothing left. The end of the world is surely right around the corner. And the president, he was an analytical sort of fellow. He was a physics professor as well as a president. And he said, well, I really beg to differ. He said, I think that there has to be so much more out there to discover. He says, as a matter of fact, I would make a prediction that within 50 years, man will fly. And the bishop just got so upset, he got flustered. He said, there is no way, man will never fly. Only angels were intended to fly. If God had intended for man to fly, he would have given man wings. And the college president said, well, I really think you're wrong. And that bishop's name was Bishop Wright, and it just so happened that his sons were a little more future-looking than he was, because his sons were Orville and Wilbur Wright, and they did one day fly and were able to see the future a little better than their father was. And I'm thankful for people like the Wright brothers, like foundations such as the Noble Foundation, institutions such as OSU Okmulgee, that look to the future and can see what the future can be and help others endless possibilities. And that, after all, is what education is all about. Thank you.
That about concludes our program, and there are, of course, always some changes that need to be made, whatever is written in your pamphlet. I want to, as you can tell by looking at me, I never want anyone to miss a meal. So there will be a meal right around 12, right, Bob? And Bob has a few other changes and or notations that he wants to bring to your attention. So I'll turn it back over to Provost Klabenes.
Before I make a couple remarks, I do want to thank Dr. Keener and Dr. McMurray and Senator Sheridan and Representative Lease and Paul and Kirk all for being a part of the program this morning. I thought they did an exemplary job. Truly appreciate their participation in the program. The automotive technology advisors with Steve Doty, the department head, when you meet after lunch, you are going to meet in the Beerson Lounge of the Student Union. The Beerson Lounge of the Student Union when you meet after lunch. Lunch, as in your program, will be in the state room, and there is not a program during lunch. It will be in the state room and go, and then after lunch is concluded, then you will go to the respective departments with your department heads. As Paul said also, we want to encourage you, if you have a little bit of time, because we have gained just a few minutes, if you want to tour any part of the Noble Center this morning, please feel free to do that. With respect to the technology demonstrations, essentially these will be a come-and-go, hands-on kind of demonstration. So you can stay in one the whole time, or you can go to 2 or 3. But the reason that we wanted to do these kinds of demonstrations this morning, or presentations, was to give you an opportunity to share with one another and also have faculty and other individuals that have come to the institution share with you some of the kinds of technology that we're dealing with at the institution in an attempt to keep current and provide the students with what they need for the 21st century. So the first one, doing business through electronic commerce, that JIT just in time, that will be in one of the seminar rooms to my right in the new part of the facility. There's 2 seminar rooms as you go down that hallway. And then the instruction and training over the internet and interactive disc, that will be in another part of the seminar room. The customized training for industrial partners, Ditch Witch training demonstration, will be right over here to my left. And you can see the Ditch Witch machine inside. And that's going to show you and demonstrate working with a customer in terms of providing customized training and give you some overviews and highlights of that. Windows 95 is 105, which is this room right here. PLCs, programmable logical controllers, room 107, that's down the hall and just to the right, room 107. And then electronic motors and generators, room 108, is down this hall and just to the left. And learning in the networked computer environment, that's the hall to my left, and the north side over here, 101 is that way, out through these doors and to the left. And then also image manipulation, Adobe Photoshop will be in the seminar room, and the virtual reality that Tom mentioned earlier will also be in the seminar room. And then the distance learning interactive demonstration will be right here in this particular room here on the right. So those are the seminar sessions that will, or the demonstrations that will be taking place. And as I said, please feel free to visit 1, 2, or 3 of them. And probably about 11:40, 11:45, if you want to make your way to the stateroom, then they'll be ready to serve lunch. So I will not see, I'll see you, but I will not see you as a group again. But I want, again,
student, and something that concerned me about my ability to get a job in the future. And I had very little, and I did have a personal computer though. It was state of the art at that time. It was an Apple IIe with a green screen and no hard drive, and I didn't have a printer, but I was up to the minute at that point, and I got it free from my brother, so it was really good. But I didn't have a personal computer, and I remember talking to Dr. Klabenes, and I remember his asking me what I thought about using the computer computers in the classrooms. And of course I said, well, I think they're wonderful, because I know that's what he wanted to hear, and I wanted a job, so I said, I think they're wonderful, and I'm ready and willing to do it. And that first year, we opened a writing studio, which was a computerized classroom, a new thing for the English faculty. And I was one of the first ones to jump in and begin using it. And I found out that I do think it's wonderful. I've used computers and technology in many ways. We have the writing studio. We've opened up another writing studio since then. I'm in charge of the Skills Center, which is a computerized lab that's over in part of the library right now, and eventually part of the new addition to that facility. So computers and technology have changed. And from the aspect of an instructor, technology has changed how I teach as well. The classroom is now much more learner-based instead of teacher-based. I'm not those who speak and teach in a computer classroom are not the know-all of everything. We are much more focused on the learner. Learning is more collaborative, more flexible, more open. And these changes are not always easy to make or easy to get comfortable with. They sometimes mean rethinking our approach to teaching and to learning. And the second phase of the Noble Center here is another step in that process of changing to meet the technological demands of tomorrow. As faculty members, we welcome the changes, usually, and although they may sometimes cause us to move from our personal comfort zone, we know they really are for the best. In closing, I'm reminded of how we must continue to look forward in order to make true progress. It really has always been that way. I'm reminded of a story many years ago. A bishop was visiting a friend of his who was a college president, and they were having dinner and they were talking about the future. What does the future hold? And the college president asked the bishop, he said, what do you think lies in the future for us? And the bishop said, well, I'm firmly convinced the end of the world is soon to come, because man has discovered all there is to discover. We've invented all there is to invent. There's nothing left. The end of the world is surely right around the corner. And the president, he was an analytical sort of fellow. He was a physics professor as well as a president. And he said, well, I really beg to differ. He said, I think there has to be so much more out there to discover. He says, as a matter of fact, I would make a prediction that within 50 years, man will fly. And the bishop just got so upset, he got flustered. He said, there is no way, man will never fly. Only angels were intended to fly. If God had intended for man to fly, he would have given man wings. And the college president said, well, I really think you're wrong. And that bishop's name was Bishop Wright. And it just so happened that his sons were a little more future-looking than he was, because his sons were Orville and Wilbur Wright. And they did one day fly and were able to see the future a little better than their father was. And I'm thankful for people like the Wright brothers, like foundations such as the Noble Foundation, institutions such as OSU Okmulgee, that look to the future and can see what the future can be and help others get ready to meet those possibilities. And that, after all, is what education is all about. Thank you.
That about concludes our program, and there are, of course, always some changes that need to be made, whatever is written in your pamphlet. I want to, as you can tell by looking at me, I never want anyone to miss a meal. So there will be a meal right around 12, right, Bob? And Bob has a few other changes and or notations that he wants to bring to your attention. So I'll turn it back over to Provost Klabenes.
Before I make a couple remarks, I do want to thank Dr. Keener and Dr. McMurray and Senator Sheridan and Representative Lees and Paul and Kirk all for being a part of the program this morning. I thought they did an exemplary job. I truly appreciate their participation in the program. The Automotive Technology Advisors with Steve Doty, the department head. When you meet after lunch, you are going to meet in the Beerson Lounge of the Student Union. The Beerson Lounge of the Student Union when you meet after lunch. Lunch, as in your program, will be in the state room, and there is not a program during lunch. It will be in the stateroom and go, and then after lunch is concluded, then you'll go to the respective departments with your department heads. As Paul said also, we want to encourage you, if you have a little bit of time, because we have gained just a few minutes, if you want to tour any part of the Noble Center this morning, please feel free to do that. With respect to the technology demonstrations, essentially these will be a come-and-go, hands-on kind of demonstration. So you can stay in one the whole time, or you can go to 2 or 3. But the reason that we wanted to do these kinds of demonstrations this morning, or presentations, was to give you an opportunity to share with one another, and also have faculty and other individuals that have come to the institution share with you some of the kinds of technology that we're dealing with at the institution in an attempt to keep current and provide the students with what they need for the 21st century. So the first one, doing business through electronic commerce, that JIT just in time, that will be in one of the seminar rooms to my right in the new part of the facility. There's 2 seminar rooms as you go down that hallway. And then the instruction and training over the internet and interactive disc, that will be in another part of the seminar room. The customized training for industrial partners, Ditch Witch training demonstration, will be right over here to my left. And you can see the Ditch Witch machine inside. And that's going to show you and demonstrate working with a customer in terms of providing customized training, and give you some overviews and highlights of that. Windows 95 is 105, which is this room right here. PLCs, programmable logical controllers, room 107, that's down the hall and just to the right, room 107. And then electronic motors and generators, room 108, is down this hall and just to the left. And learning in the networked computer environment, that's the hall to my left, and the north side over here, 101, is that way, out through these doors to the left. And then also image manipulation, Adobe Photoshop will be in the seminar room, and the virtual reality that Tom mentioned earlier will also be in the seminar room. And then the distance learning interactive demonstration will be right here in this particular room here on the right. So those are the seminar sessions that will, or the demonstrations that will be taking place. And as I said, please feel free to visit 1, 2, or 3 of them. And probably about 11:40, 11:45, if you want to make your way to the stateroom, then they'll be ready to serve lunch. So I will not see, I'll see you, but I will not see you as a group again. But I want again to